A planetary nebula is a glowing cloud of gas created when a dying star sheds its outer layers. These objects form near the end of the life of stars similar in mass to our Sun. The exposed hot stellar core illuminates the expanding gas, producing the colorful structures astronomers observe. Despite the name, planetary nebula have nothing to do with the planets. When astronomers first observed these objects in the 18th century, they appeared as small round disks through early telescopes. The famous astronomer William Herschel thought these resembled distant planets. Because of this visual similarity, he called them planetary nebula. Later researchers revealed that they were actually expanding clouds of stellar gas. Planetary nebula form when a sun-like star exhausts its nuclear fuel. The star expands into a red giant and begins losing its outer layers. Powerful stellar winds push gas away from the star, creating a shell that expands into space. At the center remains the exposed stellar core, which will eventually become a white dwarf. The central star of a planetary nebula can reach temperatures above 100,000 degrees. Its intense ultraviolet radiation ionizes surrounding gas. When electrons recombine with atoms, the gas emits light at different wavelengths. Different elements glow with different colors, producing the beautiful patterns seen in telescopes. The colors in planetary nebula images correspond to different chemical elements. Hydrogen gas often appears red, while doubly ionized oxygen produces green or bluish light. Astronomers frequently use special filters to isolate these emission lines. By studying these colors, scientists can determine the chemical composition of the nebula. These are four well-known planetary nebulae observed by modern telescopes. At the upper left is the Ring Nebula in the constellation Lyra, one of the easiest planetary nebulae to observe with the small telescopes. Next is the Cat-Eye Nebula, famous for its complex shells of gas. Below is the Helix Nebula, one of the closest planetary nebulae to Earth. Finally, the Butterfly Nebula shows how stellar winds can shape the expanding gas into dramatic forms. Although they look very different, all of these objects form when sun-like stars shed their outer layers near the end of their lives. Planetary nebulae are surprisingly large. Many expand to about 1 light year in diameter. The gas typically moves outward at speeds of tens of kilometers per second. Although these structures appear dramatic, they are short-lived on the cosmic timescale. After roughly 10,000 years, the gas disperses into the surrounding interstellar medium. After the outer gas drifts away, the remaining stellar core becomes a white dwarf. These objects are extremely dense, containing roughly the mass of the Sun compressed into the sphere about the size of the Earth. A white dwarf no longer produces energy through nuclear fusion and slowly cools over billions of years. In about 5 billion years, our Sun will follow the same evolutionary path. It will expand into a red giant and eventually shed its outer layers into space. For a brief time, the solar system will be surrounded by a glowing planetary nebula. The remaining core of the Sun will become a white dwarf. Planetary nebulae represent one of the final chapters of the life of Sun-like stars. When these stars shed their outer layers, the hot central core illuminates the expanding gas, creating some of the most beautiful objects in astronomy. After the nebula fades, the remaining stellar core survives as a white dwarf. Thank you for watching.